Welcome to the presentation on solving knowledge gaps in AI models. Today, we'll explore two advanced architectures, retrieval augmented generation and cache augmented generation. Both of these approaches aim to address the knowledge limitations present in traditional AI models by providing real-time access to relevant data. The knowledge gap problem in AI models. AI models face several knowledge gaps that can significantly impact performance. These gaps arise from temporal limitations, where models lack access to recent events, data access barriers, where models cannot access proprietary or specialized data, and hallucination risks, where missing knowledge can result in fabricated or incorrect responses. All of these factors make it difficult to rely on static knowledge, especially when up-to-date, specialized, or proprietary information is critical. Retrieval Augmented Generation RAG architecture. Let's take a deep dive into Retrieval Augmented Generation RAG. The RAG architecture works in two phases, the offline phase and the online phase. In the offline phase, documents are chunked into smaller segments and vector representations are generated and stored in a searchable database. In the online phase, a user query is converted to a vector, relevant chunks are retrieved, and this context is added to the original query. This setup ensures that the model has access to the most current data through real-time retrieval. Moreover, the architecture is scalable, capable of indexing millions of documents while only retrieving relevant subsets for each query. Cache augmented generation. On the other hand, cache augmented generation takes a different approach by preloading all relevant documents into the system's context window during the preloading phase. This method stores knowledge in an internal cache, allowing for a single forward pass during the inference phase without needing to retrieve additional information. The result is low latency and fast response times. However, the key limitation of this method is the size of the context window, which restricts the amount of knowledge that can be cached. RAG versus CAG. RAG versus CAG, head-to-head comparison. Now, let's compare RAG and CAG directly. When it comes to accuracy, RAG excels, especially with proper retrieval processes. However, CAG offers low latency and is significantly faster because it doesn't require retrieval steps. Scalability is a strong suit of RAG, which can handle millions of documents, while CAG is limited by its context window. For data freshness, RAG is more flexible, allowing easy updates to the vector database, whereas CAG requires full recomputation of the cache for each update. When to choose, RAG versus CAG, use cases. Choosing between RAG and CAG depends on the use case. RAG is ideal for large knowledge bases with frequent updates, such as in legal research, news and media analysis, and healthcare systems where recency is crucial. CAG, on the other hand, is perfect for fixed knowledge content with low latency requirements, such as customer support, technical documentation, and educational tools. Decision framework, which approach to use. To help you decide which approach is best for your needs, consider these questions. Do you have a large knowledge base? Do you need frequent updates? Do you require citations? If your answers are mostly yes, RAG is the optimal solution. If you need low latency responses and a fixed dataset, CAG may be the better choice. Future trends and hybrid approaches. Looking toward the future, hybrid systems combining RAG and CAG will provide the best of both worlds. These systems will use RAG for broad knowledge retrieval and CAG for frequently accessed information, dynamically switching based on the type of query. This will allow for more adaptive and efficient AI models. Along with emerging innovations like hardware acceleration, self-optimizing retrievers, and adaptive caching, the possibilities for these systems are endless. Key takeaways and next steps. To wrap up, here are the key takeaways. 1. RAG is best for large-scale dynamic knowledge bases requiring accuracy and recency. 2. CAG is ideal for smaller, stable datasets where speed is critical. 3. Consider hybrid approaches for more complex use cases. As for next steps, assess your knowledge needs, start with pilot projects to measure performance, and keep an eye on future developments like larger context windows and hybrid architectures.